The transition into ketosis, when the body shifts from using glucose to fats as its primary fuel, represents far more than a simple change in energy preference. It is a profound metabolic pivot that influences signaling pathways, gene expression, and cellular behavior at nearly every level. One of the most powerful responses during this shift is the activation of autophagy, the body's intrinsic mechanism for recycling damaged or unneeded cellular components. As carbohydrate intake drops and ketone bodies rise, especially beta-hydroxybutyrate, BHB, a biochemical environment emerges that favors repair over growth, clarity over clutter, and long-term resilience over short-term energy surplus. Beta-hydroxybutyrate, the most abundant and stable of the ketone bodies produced during a ketogenic transition, plays a surprisingly active role in cellular communication. Far from being a passive fuel, BHB functions as a signaling molecule that directly influences pathways associated with stress resistance, longevity, and autophagy. One of its key roles is to inhibit class I histone deacetylases, DACs, enzymes that usually suppress the expression of genes involved in oxidative stress resistance and metabolic regulation. By inhibiting DACs, BHB promotes the transcription of genes that protect cells from damage, enhance mitochondrial function, and, importantly, initiate autophagic processes. This autophagic support is particularly evident in neurons and liver cells, two of the body's most metabolically active and vulnerable systems. In neurons, where oxidative stress and misfolded proteins can quickly lead to dysfunction or cell death, the presence of ketones and the onset of autophagy work together to clean up cellular waste, stabilize mitochondria, and reduce neuroinflammation. This is one reason ketogenic diets have long been used in the treatment of epilepsy and why researchers are now exploring their potential in Alzheimer's and Parkinson's disease. By increasing ketone availability and supporting autophagy, the brain becomes more efficient at energy use and more resilient to damage. In the liver, the transition to fat metabolism and ketone production simultaneously demands and stimulates cellular cleaning. The liver must break down fatty acids to create ketones, but it also must rid itself of dysfunctional mitochondria and accumulated toxins, tasks that autophagy fulfills. The elevated AMPK activity and suppressed insulin/mTOR signaling during ketogenic adaptation provide the ideal environment for this hepatic cleanup to occur. Over time, this can lead to improved liver enzyme profiles, reduced hepatic fat accumulation, and enhanced overall detoxification capacity. But the beauty of ketogenic-induced autophagy lies not just in what it removes, but in what it empowers. As the body clears away damaged cellular parts, it makes room for renewal. Mitochondria regenerate, neurons become more efficient, and metabolic flexibility improves. Even beyond the cellular level, people often report increased mental clarity, fewer cravings, better sleep, and steadier energy, all signs that the internal systems are running more cleanly, with less metabolic noise. It's also worth noting that this autophagic benefit doesn't require prolonged or extreme ketosis. Even short periods of ketogenic adaptation, such as through intermittent fasting, carbohydrate cycling, or a few days of low-carb intake, can elevate ketone levels enough to engage the cellular machinery of autophagy. These gentle but strategic shifts into fat-burning mode act like biological tune-ups, giving cells a chance to pause, assess damage, and repair. In this light, ketogenesis becomes more than just an energy strategy. It becomes a therapeutic signal. Through the elevation of BHB and the lowering of insulin and mTOR activity, ketogenic transitions invite the body into a state of deeper listening, where metabolic excess is curbed and self-cleaning processes are prioritized. It's not about starvation, but recalibration. Not just about losing weight, but about regaining cellular integrity. By understanding this connection between ketogenic transitions and autophagy, we gain a new appreciation for the power of nutritional timing and macronutrient balance. Food choices no longer simply feed the body, they program it. And in choosing to cycle through lower carb phases that spark ketone production, we provide ourselves with the message they've long evolved to understand: clean up, renew, and adapt for the long haul.